Hi guys, so welcome back. We are going to finish question 1 from 2019 January paper 2. So we are continuing with part I. This part of the question deals with redox reactions. The reaction between iron and dichromate is considered a reduction oxidation reaction. Define the term reduction in terms of electrons. Now there is a little abbreviation that you guys can use to help you remember the definition of oxidation and reduction, and that is oil rig. Alright, so oxidation will be the loss of electrons, reduction is the gain of electrons. So to define the term reduction in terms of electrons, we can simply say reduction is defined as the gain of electrons. So make sure to write down that little abbreviation oil rig to help you remember these definitions. In the reaction, Fe2 plus acts as a reducing agent. Define the term reducing agents. For this topic, knowing the definition of oxidation and reduction as well as the definition of reducing agents and oxidizing agents are very important. So a reducing agent is one that reduces a chemical compound, usually by donating electrons. Now we need to calculate the oxidation state of chromium in that dichromate ion. There are certain rules we need to use in order to figure out this. So notice that we have a charge on our ion. Cr2O7, it has a charge of 2 minus. We are going to solve this like a little maths equation. So we are actually going to put this entire thing to equal to minus 2. The overall ion has a charge of minus 2. And this will come back from the rules. Maybe we can put the rules on the screen for you guys. There are a couple rules that we will use depending on what we are given. For a polyatomic ion with a charge, it is equal to the charge on the ion. So our first step is to write out a little statement. We are just going to split the ion here. Notice we have 2 chromium ions, 7 oxygen ions, and they are all equal to oxidation state of minus 2. So we're just going to make this into a little equation. So now I am putting the subscript as a coefficient. So 2 in front of chromium plus 7 in front of oxygen. So it's a little x plus y, and we want to solve for the unknown. From the rules, we are also supposed to know that the oxidation state for oxygen is going to be minus 2. So we are actually going to insert that information here. So that means we only have one unknown in this question. Can you guys go ahead and solve for our unknown? That is actually going to give us the oxidation state for chromium. So let's go ahead and substitute that minus 2 where we had oxygen. So if it would help you guys, instead of writing chromium, you can use x and y if that is going to help you guys figure this out. We have 2 chromium plus 7. Now we are inserting minus 2 where we had oxygen. So we have 7 by minus 2 to give us negative 2 in total. So what we will go ahead and do is you can simplify. 7 by minus 2 will give you minus 14. You want to make chromium the subject of the formula. So what we can do is we can bring the minus 14 on the other side. So keep in mind, if we carry it across on the other side, we have to change the sign in front of it. So bringing it across on this side, we will get plus 14. Going over that once more, whenever we are carrying something from one side of your equal sign to the other, we have to make sure to flip the mathematical function. So it has a negative sign in front of it. So when we carry it across, that sign is going to change to a plus. So we have minus 2 plus 14 on the right-hand side. And to make chromium the subject of the formula, we just need to get rid of this 2. So we'll divide that by 2. So when we work it out, you will end up getting plus 6. As this is an oxidation state, you need to state that plus sign because remember, plus and negative, they are included in your answer for the oxidation state. So chromium is going to have a positive 6 oxidation state in this question. And lastly, to end off this volumetric analysis question, state one precaution that should be taken when carrying out the experiment. This could be any precaution that you guys can remember from a titration experiment, or even a simple precaution on how to make sure you read your instruments properly without getting inaccurate data. So a very simple precaution you guys can put is to make sure to do all of your readings at eye level in order to avoid parallax error. Can you guys think of any other precautions? Feel free to add to this list, but you only need to give one for this particular question. So this would conclude our question 1 for January 2019. Stay tuned for other questions. See you guys later.